How's it going, you guys? It's Scott with Everyday Home Repairs, and today we're doing kind of a monster DIY install, and that is going to be installing a Mr. Cool hyperheat duct system. Now, if you're like me, you're probably familiar with Mr. Cool and their ductless mini split systems that are super popular and very DIY friendly. But Mr. Cool has had the universal for a while, which actually can replace a standard air handler, like the one I have here, which is the new Mr. Cool air handler. And now they have the Hyperheat edition, which is a little bit more capable and stretches a little bit lower into ambient conditions where it can still provide heat for your home. Now, you're quickly gonna find out, by no means am I a master of HVAC. I am kind of learning along with you, and I'm sure there's gonna be things that I do wrong, so I appreciate any feedback. If you see something I might be able to do different, maybe easier, or maybe some stuff that I'm just doing completely wrong. So I will try to roll up those lessons learned and put a link down in the description to a blog over at everydayhomerepairs.com. Now that blog will have the basic breakdown of this install just like the video will, but at the bottom of that, then it will have some lessons learned from the audience. What is that common feedback we're getting that then you can take to your project and hopefully not make the same errors or at least save some time. So let's jump right into it. We'll go through some of the basic specs so you'll see, is this gonna meet your needs? And then we'll start to actually do the install. Now, before we jump into those specs, you're gonna see quite a few different tools used. I'm assuming that you have a good selection of just standard tools. I doubt you're taking on this type of DIY project unless you have a pretty good selection. But this might be the first time you're doing sheet metal work, maybe plumbing isn't your thing, maybe the electrical. So I did put a link right below in the description over to a very specific list on our Amazon store that covers this exact project. And then I kind of grouped them into the different parts of this project, which you'll also see broken up into chapters on this video. So I've tried to break those up so you'll see the different sections, and then if you need to jump around while you're taking on this project yourself, or you need to reference those tools over on the Amazon store just so you know what to get either from that Amazon store, or if you're going to the home improvement store, you can. But also let me know if you have any questions down in the comments, and I'd be happy to help you out. So just the general dimensions of this unit are gonna be 21 inches by 21 inches, so it's truly a box. And then the unit is just over 49 inches tall. Now you'll see in my install, since we're in the basement, I will have to set this on a stand in Plenum, so that will raise the overall unit quite a bit. These units can range from 24,000 BTU to 60,000 BTU, and there's 4 levels in between there. I have the 36,000 BTU, which will fit my needs for this home, and I'll point you to the description a little bit later on and kind of sizing your unit so you can get the right one for your application. Now, I'm used to mostly gas furnaces, and in this old house, I actually had an oil burning furnace, which is almost non-existent in Illinois. So that is out, and this is now our new system that's gonna kind of set exactly where that unit was and try to utilize the return and ducts that were there before with obviously some modifications. But I can say initially, build quality, 2 thumbs up, and it does have a 10-year parts and labor warranty, which is definitely uncommon for most brands and something new for the hyperheat unit itself. Now, if we take off this panel, you can see the overall configuration. The standard configuration would be an upflow. You bring your return down and up through the unit. We have our evaporator here on the bottom side. Then you'll see the blower here. And then up top is your control board, and you have an optional area. So if you need a little bit more heating capacity, there are several layers that you could actually install right here, which are pretty much just coils to give you more heat for your overall unit. Now that standard configuration will be upflow, and then if you lay it down horizontally, it'd be when your return is going from the right side and moving left. So horizontal left would be your standard configuration. If you need to, for whatever reason, go return downflow through the unit, or flip it over where your return is on the left side and moving through the right, so horizontal right, those would need reconfiguration of the evaporator. So just know that if you have that set up, you're going to have to do a little bit more reconfiguration of this unit so it's properly configured for your application. And then the only other thing to note is I'm used to 120 volts as the power for the air handler. You're going to need a 240 15 amp breaker for any of the units from 24,000 BTU up to that 60,000 BTU. And then your outdoor unit is obviously going to be much larger. That's a 240 volt. And in my case, with the 36,000 BTU, it's going to be a 50 amp breaker. Now, I didn't really document this concrete pad, but I want to give you a little bit of information just for your reference. It's great to put a concrete pad so this outdoor condenser actually has a secure foundation and it doesn't start leaning over time. There are some situations where you might be mounting it to brackets to your home, but if you have the ground mount like this, I do recommend a pad. This one is 24 inches by 48 inches long and 5 inches thick. 5 inches is a little aggressive, but I just wanted something secure. And then I use 4 Tapcon concrete anchors, 3/8 of an inch by 3 inches, to go ahead and secure each of the 4 mounting locations. And that gave me the secure mounting location spaced correctly from my wall. So do check the instructions just to make sure you have the clearance as recommended from Mr. Cool. So first up, I am going to tackle getting all the ductwork together, getting everything lined up, everything from my existing cold air return. So this is going to come down and that's going to go into the bottom of a stand and plenum that the actual Mr. Cool unit is going to sit upon. So we will have some fabrication to get the existing ductwork to line up with what we're bringing in new. And then we'll have to do quite a bit of work again, bringing my 2 ducts that will go out to all my vents or registers in the house down to the actual air handler here. So I'll probably tie these together in kind of one plenum and then build some custom fabricated sheet metal down to actually fit up to the Mr. Cool. That's the plan for now, but you do have to kind of walk through this, and this is the thing where it's going to be custom for all of us. So you do have to kind of stand back, make a plan of attack, and make sure you're considering both if you start at the cold air return, okay, make sure you're also considering where do we need to be at for our ducts, because you don't want to get one all the way completed, but then you didn't consider the other one and you have to start undoing your work. So as a DIYer, we probably have pretty limited experience, which I do, with fabricating custom. So you gotta think through that and try to get the shortest path to get what you need and avoid any rework that you have to do. Now I am a wide open space here. If you are in the closet, you need to think through that as well. As you start to put your ductwork in place, you're gonna start to lose access to certain sides. So the way you're bending some of your lips, the way you're fastening it together, you have to think through that in terms of how much space you have, especially when you're dealing with a utility closet. And then don't forget, you'll be dealing with sheet metal and a ton of sharp edges, and it will cut you right open. So cut resistant gloves are highly recommended, and probably even some eye protection is not a bad idea. So for the base, this needs to be a stand that can support the weight of the Mr. Cool, but also the plenum for the cold air return to come into. I used a Flow-Rite 21-inch standard filter box as my base. This will save me a ton of time manufacturing something custom myself because they've really planned it out and done it for me. And overall, it just snaps together. You can see we have both of our side pieces. The shorter piece there is actually going to be the front of the unit, and then we'll put together our back piece here. Once you have that all together, what you want to do is make sure everything is lined up. But I'm going to use my Klein Tools multi-tool, which has bits in it and also a 1/4 inch and 5/16 inch nut driver. Super handy for HVAC work, and it fits right into your impact driver as well. So let's go ahead and check and make sure front, back, and both sides are lined up before we put sheet metal screws in. So I have a little bit of a bend here that I need to adjust. Once that is adjusted, now I can put the sheet metal screws, one in each of the corners. Make sure you have those driven all the way in. Sometimes if you don't drive them far enough, it'll actually just push one side of the sheet metal opposed to actually pulling those together. Now we have our S cleats. I'll put it on the back, the side, the other side, and the front, making sure the opening is pointed to the outside. So now when we put this bottom piece on, everything lines up, and we're able to secure that with 2 sheet metal screws, one on each side. Flipping everything over, we have just a little piece on the front, which will be secured with 4 panhead screws. And that's because the unit will actually sit on top here. So we want that pan head to make sure we don't have any screw heads that the furnace is going to be sitting on. And then this is also a filter box. Now the Mr. Cool has a filter channel itself, but this would allow you access with 5 screws mounting a piano hinge. And then we'll go ahead and put the knob on there. So this could also be your filter box depending on what unit you're using. And as such, we'll put those channels on each side so the filter will fit correctly. So now getting the actual air handler unit on top of that stand, if you only have one person, it can be a little bit tricky. I'm gonna try to do it by myself, but I am gonna kind of try to work smarter, not harder. Let's see if that works out. So I do need to make a small modification here. I'm just gonna put a filler piece in here to fill a gap. Again, the flow rate is awesome in terms of how fast it was to build this out, but it isn't exactly the dimensions. It was the correct width at 21 inches, but the overall length is much longer than the actual Mr. Cool. So I'm kind of splitting the difference, putting some of that in the front, utilizing the sheet metal we already had up front, and then I'm just gonna put a filler piece in here that's gonna do 2 things. It's gonna seal it off, but also I'm gonna be able to set quite a few screws in here and give a little bit more structure. You don't want your actual weight away from the corners when you have a sheet metal box like this, because that is actually where all your strength is at. So if you're putting the weight in the middle, that's actually resting off very thin sheet metal. So you want to do something that's actually going to bring a little bit more structural integrity to your box. So that is why I'm going to put that extra piece to seal it off, but also tie things together. Now for this project, you're going to see me using a ton of things like the flow right box, obviously the Mr. Cool Hyperheat, but a ton of different parts and supplies and tools. But you can look below the video and there'll be a link to a complete list over on our Amazon store that's going to give you every part and every tool that I used throughout this whole project for your reference, just in case you're taking on something like this yourself. So to try to save some time on custom fabricating different components of the release return, I went ahead and purchased a filter rack. So this actually is going to serve 2 purposes. It gives me my 90-degree angle. It fits my actual flow right stand and return here. And it's 25 inches wide and 17 inches high. So it's going to take up quite a bit of the space here on the side. So I'll make sure that we get some structural integrity back in once we set all our sheet metal screws. Now I won't necessarily have to utilize this, but this actually can fit either a 1-inch or a 4-inch filter. So if I wanted to put a larger 4-inch filter into this unit, I could in the future. Now the way I'm going to mount this, I'm actually going to use the top fold here and this lip and hook it over, so a lot of the weight will go right off the top of this lip from the flow right side, and then we'll get everything lined up on the side. I'll make some marks on the side so then we can cut off our hole to make sure we open everything up before securing this filter rack to our base here. And then whenever possible, use the ductwork that you removed. So this is the section of the cold air return that I removed from the old oil burning furnace. Now I just had those temporary stands so I could sink a few sheet metal screws, and now I'm lining up each of the 4 different S channels. Once I get those lined up, top and bottom, then I can go ahead and just sink a couple sheet metal screws in each side and everything will be secure. So now I'm starting to lay out this kind of completely custom piece of ductwork, and being a DIYer, I don't have a ton of experience with this. So I approach it by doing one side at a time, understanding where my S channels are gonna be to connect my different sides, and then also where I need a 1-inch 90-degree bend as a screwing surface for the next part of that custom ductwork to come in. So you take your measurements, your biggest measurement, you cut off your rough shape so you can put it up to where you need to do your custom cut, and then you do your markings, hit your straight edge, and then you'll start to get your actual piece sized to exactly that size. Take your time, especially when you get started, because you can easily forget to add the 1 inch for that 90-degree bend, or measure slightly off, and then you're starting over, having to go get additional pieces of sheet metal. Now I have 2x3 sheet metal and 3x3 sheet metal that I was able to pick up down at the big box store. That should cover me for any custom ductwork I need. And then also here in a few minutes, I'll show you how to strengthen these pieces so when the Mr. Cool unit turns on, you don't have that warping sound from your ductwork. So this is what I mean on planning it out. So we got our one small piece in. Now I'm gonna do this back piece. A lot of different things going on here. So one, I'm going to have to bend a 90 off this back piece so I have a screwing surface here so I can screw from this piece under and secure these two together. So that's gonna have a 90 coming in here. Here, I'm gonna connect to the existing ductwork through this S channel. So I need 1 inch further to go into that S channel so then we can sink the screws through the S channel to secure this surface. Then I'm just gonna have a straight edge to the top all the way across here for the full length. And I have an old ductwork attachment mechanism with all these little tabs. So what that means is I'm gonna have to cut out this ductwork hole, and then from the inside, and that's where the order of operations comes in, because I need full access to the inside, I gotta bend each one of these tabs over to secure this ductwork into this custom piece that we're making. All the while, I need to think through this next piece and my top piece, knowing who's gonna have the 90-degree angle so we can have a screwing surface. So you gotta think through all that before you start cutting, or you might leave off that extra inch and then you're gonna have to start back over. So I just finished up that side piece. Now we got top and front surfaces. Now when you have wide open pieces of sheet metal, this back one probably should have creased this to give it a little bit more structure to avoid any wobbling or noise. There is a little bit of movement there. We'll have to see once we kick on the unit if that airflow actually makes that wobble. I think we'll be all right, especially when I secure this back surface and get that top section on that should secure it up. But this front surface is going to be wide open, so I'll show you how to set those creases to give it a little bit more structure than just one wide open piece of sheet metal, because that would have a tendency to bow in and out, and it's going to make a lot of noise when your unit's turning on or off. So for this top piece, I actually made 2 different 90-degree bends. So that's going to give us our screwing surface for the back and for the front. So just seeing if everything lines up here, I want to start setting some sheet metal screws. Since we're getting to the end of making this custom box, I will start setting more and more sheet metal screws to make sure everything's pulling together and we don't have any big gaps or any issues that I overlooked. Now, once I get that in play, and you'll see that right-hand side's kind of bowing out, we'll take care of that here in the last piece. I'll get my maximum width and maximum height to get that sheet metal. Make sure that I have enough room. And the sheet metal I had was actually 33 inches, not 36 inches, so it's just gonna be long enough for this piece. I'll mark both those back angles, which I'll go ahead and cut. So I have my last piece here. I have it cut to size, and I do need to give a little bit more structure to this one because it's just gonna be a wide open piece and it's gonna tend to warp. So all you really need is a screen spline roller. So this would be when you're making screens and you're rolling the spline to hold the screen into your window screen. This works perfectly for this. You just need another straight edge, and then you're just gonna find your kind of crisscross lines here across your piece. It does not need to be perfect. Now I want to actually make this line from the back side so that is pushing out, and I have the ridge that I'm going to create pushing to the outside. Make our first one here. So nothing too special, you just want to get that nice crease, and then obviously we need one in the other direction. So this is what you're looking for, just a simple crisscross pattern. Once we screw this in, now we should have a lot more structure to this wide open sheet metal piece. So now is the moment of truth. We're putting that last piece into place and see if everything lines up. If everything's looking good, you're gonna start to pull that together with a lot more sheet metal screws, but don't just focus on one end because you might be pushing something out of place on the other end. So kind of go back and forth, pay attention to what you're doing to make sure it all comes together. Now you will have time later on once we're testing out our unit to seal everything off, but this should be pretty close to your finished product. And I'll give you a much closer look. We'll take a walk around because this isn't perfect. Obviously, as a DIYer, it could be better, but overall, it's definitely gonna work for this application. So here is your closer look, and the lighting won't be great, but I do have very small gaps like that where I'm gonna have to seal things up. Maybe pull that in where a crease is bowing out. Little bit of a gap here. We're coming from the new to the old, not too bad. That ductwork coming in the back's looking pretty good. But overall, there is a question whether or not this is gonna give us any issues, but it's pretty strong overall. Switching over to this side. Transitions are pretty good. We'll have a little bit of leaks here and there, but to be honest, I am pretty satisfied, that being my first full custom piece of ductwork that I've made. So next up, I'm gonna blaze through this guy. This is gonna be a lot easier, connecting my cold air return, and I'll just be calling out any differences in the process between the one we just created and pulling this together. Now, if you're pretty new like me, let me just give you an overview of some of the tools and parts that we're using for this so you can relate it to your own project. We're all going to have a little different work that we need to do when it comes to the ductwork, but here are a few tools that come in handy. So right here, this is a little folding tool. I use it right here to form up the ductwork and make my 1/2 inch fold here. And then that 1/2 inch fold would go onto a C-shaped cleat, which would then slide in from one side, and then you do the same 1/2 inch fold on your bottom piece, and then that's how you attach these two sides, is with this C-cleat. We talked about that window screen tool was going to help you create these ridges to give you a little bit more structure. You'll have a left and right hand set of snips to help you with the cuts. I use these predominantly in cutting out the hole here in my base. I use these a lot. These are just a straight cut, larger snips, and you can see all these tools in a link in the description underneath the video. Right underneath the video, it'll send you to the Amazon store, and I'll have a complete dedicated list to ductwork, furnaces, and specifically this Mr. Cool Hyperheat unit. And then you'll see all the different tools I'm using in this project, and also any relevant parts for your reference. But also don't forget you need S cleats. I have an S cleat here on the bottom and top of this piece. So C and S are going to be your two different types of cleats that are going to help tie this together. In addition to the 1-inch bends that I have on my far side, which is created by this tool, which has the end for the 1/2 inch. That's going to help you with this C cleat bend where we're folding back the 1/2 inch. And then it has the 1-inch side that I bend at a 90-degree angle, so I have that screwing surface. It takes a little getting used to, but once you get some reps and get going, it's something that you can get this put together in an hour or two without much trouble. So let's jump back in and finish off this section of the cold air return. All right, we'll give you a little bit of a close-up look. Haven't decided if I'm gonna cap that off or not. So there's our one side. Again, it is not perfect. I have a little bit of work to do on my S and C cleats, bending those back. I creased this side to give it a little structure there. Overall, gaps are not too bad. Everything's fitting up pretty nicely. The back side here. And then coming around on the inside, again, also creased, meeting up. Maybe a little bit of a gap there, not too bad. And then I don't have overlap on my cleats here. But other than that, it's pretty good. If you guys have any feedback for me, I do always welcome that down in the comments. If this is something you do for a living, I'm sorry. I know this is definitely a little bit of a ragtag DIY approach, but I appreciate your feedback. And then if you're DIY, you're going to take this on yourself, always jump down in the comments. You'll see a ton of great feedback that's going to help you out on your own project to hopefully save you time and money compared to what I did here for the Mr. Cool Hyperheat. So next up, I'm going to jump into the two 240 volt circuits we're going to need. One for the inside here at 15 amps, and then one for the outside pulling much more at a 50 amp circuit. Okay, so I'm trying to get my bearings here. I have a reference point from inside the basement, and I know I want to come over 4 of these blocks. Then I know my disconnect is going to be mounted right at this height, and I want to roughly know where then my wire is going to land, so it makes sense for where I wanted to route it. In terms of how big of a hole, I know that I'm going to run this through the back of the disconnect housing, and I want the hole to actually accommodate this so I can run conduit through the brick wall. So that is why I picked 1 9/16 inches for my masonry hole saw, and I have a pilot bit here which will hopefully help me reduce blowout by drilling from both sides. Then we'll go ahead and mark the center of that hole. So now we have the hole marked, and we'll start to drill from the outside. Now we are using an SDS Plus bit with a rotary hammer drill. This is going to make your life a whole lot easier than trying to do it with a standard cordless drill that has the hammer option. It might be worth renting if you do not have it. And you can either go with the smaller SDS Plus or even up to the SDS Max as well. So that was definitely a fail in terms of reducing the blowout. This type of brick block is super brittle. So if you want to avoid this, maybe get a spotter, somebody on the inside, and once that pilot bit goes through, stop, jump on the inside, and then use that pilot hole to then drill from the inside out, trying to reduce this blowout. So once I'm done, I'm gonna have to patch this up and then repaint it just so it isn't as noticeable as it is now. And then we'll go ahead and get our 3/4 inch conduit with the LB body attached with the conduit going outside. This is going to give us a nice path to the outside disconnect box, and we'll secure this up prior to running our Romex. So for the Romex on this 50 amp circuit, it's going to be 6-2, that's 6 gauge 2 conductor with a 10 gauge ground. I'll be drilling holes with a 3/4 inch Irwin speed bit and my impact driver. Always make sure you know what's on the other side of that joist. You don't want to hit the other yellow Romex or the blue PEX water line there. So untangle this 6-2, that's 6 gauge 2 conductor Romex with a bare 10 gauge ground. And I'll just slowly feed that over. Once you get into the thicker gauge wires, so your 6 gauge or 4 gauge, it's a little harder to pull, but even still you can do this as a one-person job. Things like that ductwork there, you're going to have to kind of snake over and maybe just do one joist at a time, but you'll be able to work it across the room if you're going through a basement such as I am here. Each one of our setups will be a little different. So once I get it over to the appropriate joist, then I'll just run it right in the middle. You can see that LB conduit body that I'll then run over to, and I'll use large staples to secure the Romex on the side of the floor joist. So then out at the disconnect, we have our 2 6 gauge conductors ready to go for each phase, and then a 10 gauge ground, bare ground coming out. Now in the middle section here are going to be the 2 line sides. So that is going to be this black conductor to the outside, white conductor to the inside. You could flip flop those around, it doesn't matter. And we'll tighten those up. And then the load, that going to the AC unit, will go ahead and go to the outside. That is how these disconnects work, right? It makes continuity between the line and the load. And in this down position, you can read on. That is when continuity is made. So you press that in, that's gonna connect it up, your unit's gonna be on. And then when you need to service it, you just pull it out, and you can flip it upside down where it's not making continuity, but you're able to store this in here so you don't lose it. So it should be noted, as you're torquing these down, go ahead and work around that conductor a little bit, because there is stranded wire in there, you want to work it around and do several cycles of tightening, because when you work it around, that will loosen things up, and then that'll allow you to torque it down a little bit more. So now we'll bring the liquid tight whip that will go from the disconnect up to our AC unit. So we'll just get this knockout out of here. And then I will angle this down just to help reduce the amount of moisture that can get into that fitting, and use my little 3/4 of an inch wrench here. So at the panel, I have my new Romex up top coming through the large central conduit. I have my two 6-gauge conductors that I'll run to this side, where I will then be installing a 50 amp square D QO breaker on the right hand side. Then I'll land my 10-gauge ground. Right now this panel has all the grounds on the left hand side, all the neutrals on the right hand side. Now this is a main panel, so I can go to either side because the neutral and the ground are actually bonded together. So I don't need to keep them separated like you do with a sub panel. As always, safety first, probably even before you get the cover off, let's go ahead and hit our main disconnect. And what I do like about the new panels is we do have covers for our main lugs off of our two different phases. So these yellow conductors will help to make it safer to work inside the panel. Because remember, even when you hit this main disconnect, the main conductors coming from your meter base, those are still live. That isn't going to neutralize those because that's coming straight from the meter base, and you are just neutralizing the two bus bars for each phase that go down through your panel. So let's go ahead and land these 3 wires and then we'll test things out. Now we'll go ahead and place our new 50 amp. And I haven't mentioned it yet, but since we're using 6.2, we have a black conductor, we're used to that being hot, and then we have a white conductor, we're used to that being neutral. But because we're using the two 120 phases, the white is actually our second phase. Sometimes you would have that as red. For instance, if you had a 50 amp oven outlet that's 4-prong, where it has the two 120 phases, the two hot conductors, it has a neutral and it has a ground. So in this case, our white is equivalent to the red here for our second 120 phase, and that is what gives us 240 volts across the two different phases. So now everything is wired up, and then let's test our work. I'll move my clamp meter so we can get the multimeter functionality. Then we'll go ahead and turn on our breaker. Black probe goes to the neutral, which is actually grounded at the main panel. Then we'll test this, getting 119.4. So our first phase looks good. We'll go ahead and test the second phase, 119.3, looking good. And then we'll move that black probe and see across the phases, we should see 238. So everything's looking good here at the panel. And now we have our new 50 amp circuit up and running for the AC unit. Now we'll need to run another 240 volt circuit, and this is going to be powering the indoor unit, predominantly just the air handler and the circuit board. So this is only 15 amp, and as such, I'm running 14-2 Romex, 14 gauge, 2 conductor Romex, which will give us the circuit that we need to power that indoor unit. Now the hyperheat system, if you need additional supplemental heat, you can get heating coils, but those coils will not be ran by this 15 amp circuit. You would have to run an additional 240 volt circuit, and we'll talk a little bit more about that here in a bit. Now, since it's a 240 volt circuit, by code, we do need a disconnect method at the actual unit. So I'm putting another 30 amp disconnect here inside, which will connect the 14-2 and then run some protected wire down to the unit itself, not just running Romex down to the unit. So similar to the outdoor unit, we're connecting up our 2 conductors, and I am marking the white conductor with red tape. This was noted by some of the viewers in my last video, and that was, hey, if you're going to use white conductor, which is usually neutral, you need to mark that because it's now a hot conductor, and that could be confusing to future people servicing the actual unit. And then we'll complete this side. This is the 15 amp coming into the actual unit, and it has a little bus bar here where we can connect our 2 conductors and our ground. So we'll have the 3 wires there. I'll strip those solid. And I'm not going to put anything on the end of these because the solid conductors can go under those plates and we can secure them down without any issue. And then the connections are completed back here at the panel for my 15 amp 240 volt circuit breaker. And just want to reiterate, since we are using standard Romex both for our 50 amp and for our 15, that was a 2 conductor Romex. So you would have black, which is usually your hot, and white, which is usually your neutral. That would be for a 120 volt circuit. Well, in this case, it's a 240 and we needed 2 hot conductors. That's why you would mark those with red. I called this out in one of my other videos, but I did not mark it, and that was a mistake. So make sure you mark those to indicate, okay, this white wire here is no longer a neutral. It is actually serving as a hot conductor in this application. And then that's gonna help out anybody in the future just make sense of this wiring and easily service the system or make changes. Now moving on to installing a drain line. Now, if you're not familiar with the coil setup here, it's very common for condensation to build up. That condensation will fall down into a plastic pan, and then from that pan, we need to have an outlet for that condensation to get away from the unit. If you do not properly drain this, that can lead to all sorts of issues and a complete mess on your floor, or if you're installing this up in the attic, even bigger issues. So I'll be using 3/4 inch Schedule 40 PVC coming out your main outlet here, and then running that back to my wall and then over to a sump pump pit. Again, your situation might be a little different. Just know you have your main outlet, and then a little bit higher right next to it, you have another outlet. That is the overflow. Usually what you would do is you would route the overflow, so if you had a blockage in your main drain line, then your path of condensation draining out would be the overflow path, and you can either put that on the floor or somewhere else where it's very visible, so you know if moisture is coming from that overflow path that you have something wrong, you have a clog in your main drain line, and you can go ahead and address that and fix it. So let's go ahead and jump in, and I'll start routing that 3/4 of an inch PVC pipe. Now you might have noticed there was no sump pump in that pit. I still need to install that, one, just to get that condensation up and out, and two, just to have a capability if the basement gets wet that we can pump the water out. And don't forget, you do need the P-trap. That is critical. And actually you need to prime the P-trap and put fluid to fill that up to make sure when you turn on your AC unit and the blower is running that no air can pass through here, because if you were able to do that, the blower fan is creating a suction. And if air was able to pass through this, then water would not come out until the blower fan turned off. Then everything would finally flush out and drain out of your system. I also have a downstream vent here to make sure that the whole drain line easily can drain out to that sump pit where we are discharging the condensation. And then whatever meets your needs for the overflow, I recommend having that going to a visible area. So if there is an issue with your main drain line, that you can see the water leaking out of your overflow, and then you can address that issue. So next up, we'll be connecting the No-Vac line set. And this is really the key part to what makes this DIY friendly, because we don't have to install our lines and then pull a vacuum. The line set is all ready to go. If you connect it correctly, you should be able to open up those valves and then everything's gonna work without calling in an HVAC tech. Then when we get that on, we'll just get our thermostat up and running and start testing out the system. So I need my second hole to the outside. This is a 3 1/8. I'm using my rotary hammer drill from Makita, which is not really cutting it. So I need to step up to my Bosch corded drill, punching out half of the hole from the inside. And then I don't want to blow it out like I did for the electrical conduit. So then I come from the outside since I had drilled a pilot hole all the way through. Much better results, a little bit of a chip there, but pretty darn clean for such a large hole. All right, so next up we need to put these cutoff valves both at the outdoor unit and the indoor unit. We'll take off the caps here, and you are not gonna put any Teflon tape on these connections. They are made to seal as they are, so you do not need any pipe dope or Teflon tape. That can just cause you some issues. Now you will need to torque these down. And for this cutoff, you're gonna need an 1.25" socket and a torque wrench, and then you're gonna torque this down to 70 Newton meters. And then for a smaller cutoff, you need a 7/8, and then we'll be torquing that down to 50 Newton meters. And then correction on the smaller one, you're actually, instead of a 7/8, you're gonna need a 15/16 deep socket. All right, so we have our two different lines, and these No-Vac or no vacuum lines come in set lengths. So 15 feet is what I got. That's about the shortest you can get. And then it's 5-foot increments from there, depending on your application. So you need to unwind these. They are gonna be a little bit rigid. Obviously the smaller line's easier to bend than the larger line. And then this small hole is gonna be a little tight for both of these going through. So I'm gonna really have to squish down this insulation to get it through the hole, but then that will just leave less for me to seal up. So hopefully I can get that through. So now I'm gonna kind of fight with these lines. I plan on coming through here, wrapping around between the air handler and the cold air intake, and then coming out on my back wall and then going straight out right into the unit. Any extra line I plan on leaving inside the basement and then having a fairly clean install right to the outside unit, which is only a couple feet from that hole or from my basement wall. So you'll have a little back and forth. Take your time. Do not overbend these lines. You shouldn't try to cut too close of a radius, because remember, these are already pressurized. That's the key to the system, and that's also why we installed those little valves there, is each of these lines has a little piston in it, and once we tighten those down, that piston is gonna depress, and that's gonna pressurize the system, and then we're gonna open up the valves, and that should mean our system is ready to go, and then we can start powering things up and getting our thermostat connected. But first up, let's go ahead and route these lines. So now our lines are fully installed. I did put two storage hooks here off some 2x4s just to help with my routing to keep it a little cleaner, but you don't obviously have to do that. And then also, I just tightened down my actual connections. I didn't have an open end for my torque wrench. So no, the best practice would be to tighten these down to 45 Newton meters for both of them, or 33 foot-pounds of torque. I just tightened them by hand, but we'll also on this step check for leaks. So really all I have is some dish soap and water. I'm gonna pour that on, maybe you have a spray bottle. I'm gonna pour it on these connections that we made, and then I'm also gonna open up these valves. So I'm gonna look for any bubbles to indicate any leaks. If we do have a leak, we want to get that stopped as soon as possible, because once the refrigerant actually goes out of these lines, if that happens to you, now you would need to call in an HVAC tech. They need to pull in new refrigerant and pull that vacuum, which they can do. In the instructions, it tells them exactly what to do, but obviously that turns it from not a DIY project and you gotta kind of call in some help. Let's go ahead and open the valves here to let the refrigerant in, both at the air handler and the outside condenser. Then open these up. They do give you a 5mm Allen wrench. All you have to do is just turn it all the way to the left until it stops. So really on the home stretch here, and now we just need to make the connection, a 2-wire connection between the air handler and the outside condenser. So we'll make that connection. And then also a connection between the air handler and a thermostat. Now when it comes to thermostats, you have about 4 different options that Mr. Cool actually provide to you. The easiest is going to be actually to use their thermostat. Now I do understand you might be a fan of Nest or another smart thermostat, so you don't really want to change to a Mr. Cool unit. You want to stick with what you have, and you can do that. Just know that this Mr. Cool unit communicates between the air handler and the thermostat a little differently than most thermostats. You only need 2 wires to connect up. We're just going to connect up 2 wires here and then 2 wires up at the thermostat once we mount it. And then that provides it the ability to communicate between the thermostat to the air handler. Unlike normal thermostats, which might have many different wires, and I am keeping my 18 gauge 7, so it actually has 8 different wires in this bundle. I'm keeping that in place. So in the future, if I want to switch to a Nest thermostat, this thermostat wire that runs between the air handler and then up to the living space is going to be the thermostat wire I need to accommodate a Nest thermostat. Why I'm going to use this Mr. Cool unit, because I just personally want to try it out. And if you use this unit, you do not have to change any of these small switches. These are called dip switches. These provide you on-off, multiple different on-offs to give different configurations depending on what type of thermostat you're using. So the default scenario is this thermostat. Check the instructions if you want to use a different one, because you'll have to change the dip switches and the wiring will be quite a bit different where you're going into your standard terminals like you might be used to on, let's say, a gas furnace with a standard air handler. One of the big things I don't like about this Mr. Cool unit is actually battery powered. So that means once your battery runs out, cooling and heating goes off. How I avoid this scenario is I actually get a spare battery and I just tape it to the mounting plate. So that way I always have that spare battery. If my screen goes blank, I can open this up and I have that spare battery ready to go and I don't have to run down to the hardware store. So just a tip for you if you're using this standard unit or really any battery powered thermostat, it's always nice to have that spare battery if you can store it in the mounting plate. So let's go ahead and wire everything up and then test out our unit. So since we are doing only the 2 wires, we're going to be going to HA and HB down here. If you were using a Nest thermostat, you would not be wiring down here. You'd be going off of these terminals here and doing more of a traditional wiring format and have many more than just the 2 wires. So then we'll go mount the thermostat and stay consistent, white going to HA and red going to HB. Again, all we're gonna need is these 2 wires. I do wanna keep the rest of these wires in place, so I am gonna just double them back, kind of spread them around the outside of the wire and then tuck this back into the wall so we only have the 2 wires coming out into the base of our thermostat. And then for the 2 thermostat wires that will go out to our outdoor unit, we're just going to be going into white will be going into S1 and red will be going into S2. So at this time we have everything connected up and we can actually test out the system, kind of the moment of truth. Hopefully everything's connected together correctly and we're able to get both cooling and heating. The nice thing is it's 75 degrees Fahrenheit today, so I can actually test out the full system. What you want to do is make sure both of your disconnects are set in the on position and then go over to your breaker box and turn on your 15 amp and your 50 amp breaker. Once that's on, your thermostat should be activated and you can turn that to cooling to start testing out the cooling functionality of this heat pump. It'll take it a little time. You'll hear some refrigerant flowing around and the outdoor unit will turn on. But what I like to do is use a little grill thermometer here and I just place this in the vents. Now initially I was only getting little under 70 degrees Fahrenheit air, but after about 5 minutes, I did start to see that progressively cool down to where it settled out at about 58 degrees Fahrenheit coming out of the vents. And overall, I was happy with that temperature and really started cooling down the space. Once that was confirmed, so the AC is working, I flipped it over to heat and I did the same test. Again, I gave it a little time and I saw the air coming out of the vent get up to about 87 to 88 degrees Fahrenheit. Again, very effective at heating. So now the system is fully tested out. It was quite a project, but I'm super happy with the overall install, but it's gonna work perfect for this property. Now, a few additional pieces of information. It's the fall right now. In the winter, I'm gonna wait till the days are extremely cold and I have an energy monitor that I'll actually place inside my circuit panel and it'll let me know exactly how much power I'm consuming with this unit when it gets extremely cold outside. It also will validate without any heating coils, any additional heating capacity. Is this heat pump effective at heating this property when the ambient conditions are super cold? And that is exactly what the hyperheat is supposed to do. So I'll validate that and include that in a video with my findings, which you'll find right here. Now, if you want to dive a little bit more into how much I spent on this unit, how many trips did I take to the home improvement store, and how long did that take, I rolled that up in this video right here, which was just a summary on can you take these projects on, what do you expect, and how much do you save? Thanks so much for joining me on this video, and I'll catch you on one of those next ones. Take care.